Greetings, dear colleagues. I present to your attention the work concept of synthesis of the digital twin of the rock massif based on the stability. Ensuring slope stability in open pit mines is a paramount concern in mining engineering and geomechanics. Over the past decades, with the increasing depth and intensity of mining operations, the significance of reliable slope stability assessment has escalated. A key indicator in this context is the safety factor of the rock mass, defined as the ratio of the actual strength of the rocks to the magnitude of the loads acting upon them. The topicality of this subject is emphasized in the works of numerous scholars and researchers, where particular attention is paid to the development and adaptation of stability assessment methods to the specific conditions of quarries in various regions. The coefficient of safety margin helps specialists assess the potential danger of collapse and develop appropriate measures to strengthen the sides of the pit. The main methods of assessing the stability of sides include the limit equilibrium method, the finite element method, and the finite difference method, as well as the discrete element method, each of which has its own advantages and areas of application depending on the specific conditions and characteristics of the quarry. Modern methods of assessing the stability of pit sides are based on a comprehensive approach to the analysis of geomechanical characteristics of rocks and their location conditions. Factors such as the geological structure of the massif, the physical and mechanical properties of the rocks, the presence and characteristics of fracturing, as well as hydrogeological conditions are important in this process. Measurements of the intensity of acoustic emissions arising from natural stresses in the massif and from additional loads added to it are carried out in the massif of rocks. Evaluate the stability of the array according to the parameters of the acoustic emission pulses. Predetermine the coefficient of friction of rocks. Explosions from rock breakers are used as additional loads. Measure the decay time after the explosions until the background level of the acoustic emission is established. In the developed methodology for determining the reserve coefficient of stability of a rock massif, which includes measuring in the rock massif the magnitude of electromagnetic pulses arising from natural stresses in the massif and from additional loads added to it, the stability of the massif is evaluated depending on the magnitude of the electromagnetic pulses. As additional loads for excitation of electromagnetic pulses in the massif, explosions during or striking are used. The decay time of electromagnetic pulses after explosions during or removal to the return of the background level is measured, and the reserve coefficient of stability of the array can be determined by the formula, where phi is the angle of internal friction of rocks, degrees, m is the maximum of electromagnetic pulses arising under the influence of the explosion, pulses per second, t is the duration of fading to the background level, seconds. The Velika Glyuvatka deposit was chosen as the research object. The measurement points are located in the east and west of the Glyuvatsky quarry. The Velika Glyuvatka deposit is confined to the southern part of the Saksagan district and is located in its thrust part. A characteristic feature of the rocks of the Kryvyra series, which make up the deposit, is their steep monoclinal occurrence with a west dip at an angle of 40-55 degrees and a north-northeast strike at an angle of 20-25 degrees. At the Velika Glyuvatka field, the largest discontinuous fault is the Saksagan thrust, which can be traced along the entire extent of the Saksagan strip and is represented by several zones of complex flaky structure. Several diagonal faults can be traced within the deposit, which are branches of the Saksagan thrust. After the explosion on August 3, 2023, the maximum intensity of electromagnetic pulses was m 140 pulses per second. The natural background was restored after t 37,200 seconds. The angle of internal friction of the rocks in this area was equal to 41 degrees. We determined the coefficient of stability of the array, which was equal to 0.241. The calculated coefficient of the stability margin is less than 1, so the array is unstable. After the explosion on March 30, 2023, the maximum intensity of electromagnetic pulses was m 55 pulses per second. The natural background was restored after t 2100 seconds. The angle of internal friction of rocks in this area was phi, 45 degrees. The coefficient of the array's stability margin was determined, which was equal to 1.102. The calculated coefficient of the stability margin is greater than 1, so the array is stable. As a result of industrial research in the conditions of the CGZK quarry, the dependence of the frequency ranges of the Earth's electromagnetic field on the corresponding depths of rock stability studies was confirmed, namely, for depths of 300-400 meters, the frequency range of 0-1 kHz is informative. For depths of up to 80 meters, the range frequencies of 1-2 kHz. Experimentally confirmed scientific conclusions that the intensity of pulses of electromagnetic radiation of the Earth's field is a derivative of natural stresses in the massif and an external disturbing influence in the form of mass explosions from the breaking of rocks. It has also been experimentally confirmed that the parameters of the transient process by electromagnetic pulses from a mass explosion, which allows determining the coefficient of stability of the mining massif. Thank you for your attention.